Hi everybody and welcome at this lesson number 6 of the motion graphics beginners class. Before we start, as usual, can you confirm you can hear me clearly today? The audio seems to be okay from my side. Just need you to confirm you can hear me properly. Great. Okay, so today we're gonna create our first animation that would make more sense. Last time we've seen some steps how to create keyframe. Today we're gonna make something a bit more complex that should be working both from 2D or 3D. So we're gonna have an overview of all the tools that we used till this moment, and we're gonna use them all or most of them. We're gonna also, after we create the animation, we're gonna see how to play a little bit with the render settings, and how can we add some more material, a bit more complex material, so a step ahead compared to last lesson. So first thing, we remove, as usual, everything. We're gonna recreate the camera later. We select everything and remove everything from the scene. At the moment we don't need the 3D cursor. Usually we hide it. And what we're gonna create is a solar system. Probably not our solar system. It's not gonna be anything realistic at the moment, but it's going to be a planetary system. So we're gonna have a star that will be in the center, and then we're gonna have planets revolving around the sun, and we're gonna have satellites revolving around the planets. So we're gonna use, of course, the classic color or of planets we know, and we are gonna actually call the planets as the planets in our solar system, but just to have a reference name instead of calling them with codes or fantasy names. It's going to be even more complicated. So we start easy with an object that we will call sun. We can create, we're going to use only UV sphere for today. So the difference is the geometry, how the sphere is made. This is an UV sphere, while the icosphere has a different geometry. Doesn't really matter at this point, but we want something that has a north and south. So while this sphere is basically symmetrical from any point of view, once they are smooth shaded, they look the same. This just needs more subdivision, but they will look as two spheres. The difference is that this one will have all the geometry laid out from one side to the other and circle around. So don't worry too much about when you need one and the other. Right now we are creating planets, and you know, planets are not completely spherical, and we also are used to have parallels lines on our maps, so we're gonna use what is closer to what we know. So it's gonna be this kind of object, which is called UV sphere. So this one is gonna be our sun. Let's name all the objects we are gonna create. We're gonna name them so we know what we're gonna do. Sun, and if you go from the top, you can clearly see that the north pole of the sun is pointing at us, and we can actually create all the rest of planets from here at this moment. So let's create another object, a bit farther that we will call Mercury, and it's much smaller, so we press S and we shrink it. Again, they are not in scale because it will take a lot of estate and the whole animation won't be visible. So we just try to scale them a little bit to give an idea of proportion, but not really anything precise. Then we're gonna have our Venus, and we're gonna have planet Earth, let's say here. Oh. Which is gonna be slightly larger. When I'm copying the objects, I'm clicking Shift D and then I press X, so I'll move them only on the X axis without having any major movement going on. So this is gonna be Mars, and then we create another one which is gonna be Jupiter, which is much bigger than Mars, probably much more than this, but it's not a problem for now. And then we're gonna create something slightly smaller. I don't know how smaller, but it doesn't matter. It's just gonna be Saturn, and we create Uranus and Neptune. Pluto is too small, we're gonna keep it out of the lesson for now. Also, Pluto has a different orbit, so it will probably be a bit hard to visualize it in this animation we're doing. So we have the name of the planets, that's good, and then we need to let's say that we know for sure that the Earth takes 1 year to go around the Sun, so we'll start with the animation of our main planet. And if we rotate this object, it's rotating around its own axis, so that's not what we want. We want the object to rotate based on this center, so the center of the Sun. So there are multiple ways of doing this. You can of course select this and parent to the Sun with Ctrl P, which means if I rotate the Sun, the Earth will rotate around it, but that's not what happens because the Sun doesn't rotate like this. The Earth rotates based on the Sun center, roughly the Sun center. We are going to create completely circular orbits. We're not going to have ovals and going into something too scientific. We're going to just make a visualization. Don't forget, this is a motion graphic. It's not scientific animation. We are not going to make anything for like 3D, proper 3D realistic illustration. Yes, something may be realistic, but this one is just visualization. So it's the concept of planets rotating around something else. That may be any other objects, of course. This is just to have something to understand while we talk, something that makes some sense instead of having random objects. So the thing that we have to do, it's moving the origin of the Earth, which is also the center of mass in our case, to this point. So we go here, options, and let's move origins. So once we select the object, now we are moving the origins. So we select the first one, press G, press X, and also I'm gonna press Ctrl, so it's gonna snap. The only problem with this system, hello Brian. Yeah, we are all locked down. We are all in lockdown. So good day to you. If we press snap, the snap will be based on the position of the Earth, and we didn't snap the Earth in the beginning. So what we can do would be moving this, but it's not doable. So we can go into, first of all, I would select the planet. Sorry, we go origins again. And if we go into the snap, we can snap based on, let's see, vertex. It should work. So now we can take our center again, so G and X, only on the X axis, and then Control, and then we'll be able to snap it here. Same thing for all the other objects in the scene. We're going to snap it there. Oops. So again, I'm pressing G, while here origins it's selected. I press G, press X, I press Control, and then I move as close as possible to the vertex, which is the center of the sun in this case. So what I changed, again, it's the kind of snap I'm using. Instead of being based on increment, that will be an increment from the current position or the current value, I'm using vertices. There are other ways you can snap it, but at the moment vertices, it's good enough, and it's gonna be center, not closest or anything else. You can enable the snap clicking here and it will be always active, or you can just press Ctrl and will be temporarily active. So if I don't press Ctrl and I click here on the magnet, I press G and I move it here, it will just work exactly in the same way. Then I need to remember to deactivate the snap. Or if you know what they're doing, just press Ctrl and it will be automatically active or inactive. Okay, so we have now our objects that are going to rotate based on this center. Now if you remove here origins, you see that each single object has the center in this point. Okay, so some people have problem with my volume is that the maximum volume. Unfortunately, I don't know. Can you confirm that everybody can hear me properly? I don't know what's going on. It might be YouTube. I didn't change anything from the beginning of the stream. Let me see if I can increase it even more. Device properties. Brian, Sam, can you hear me properly? Okay, so probably computer killer, you need to I don't know, increase your volume. I have my microphone at the basically highest volume I can get, so I don't know what to do more than that. Okay, cool. Okay, so let's go on. Right now, my objects, all of them, have their center here. So remember the center, this orange dot was in the center of the object. Now I move it over here. And what I'm gonna do is to test if it works. Let's say that this is our planet. If I press R to rotate, or if I press this icon, you see where it's gonna rotate. So it's showing me this point because it will rotate based on his origin. So if I press R, you don't see the same gizmo, that's how it's called, the control for the rotation, but you see this icon instead that will show you the relationship between your object and its own center. So right now it's rotating right. So what I'm gonna do is start with the animation. We are rotating the Z axis, so we're gonna add a keyframe. Sorry, we're gonna add single keyframe on the Z axis because I don't care about the rotation of all of the other axes. And now it's keyed here, and actually we can create the same for each single planet because we are gonna make our animation start as they were aligned. So insert single keyframe, insert single keyframe, select, insert single keyframe, or we can do press I and click on rotation, but that will add a keyframe on all the axes. So then you will have to go here and delete the keyframe that you don't want. So in this case, it's faster probably to insert the keyframe like this. There are not many objects, so we can do it. Okay, and now every single object will rotate around that center. I believe that I should have done the sun a bit bigger, and I should move maybe I should scale. If I scale, it will still work. I will scale all of them. Let's make the sun a bit smaller. Okay, let's scale this on its own place. Okay, so I just change a little bit the dimensions, and now we have all the keyframe for the first frame, and we go to the, let's go to 250. We're gonna make a 10 seconds 25 frame per second animation. So also go here and set it to 25, and let's say that I want in 10 seconds for the Earth to do let's say two years, so 2 revolution, 1 and 2. So I can do this. Of course it's not precise. You can see on the top left of this screen that the rotation degree will change, or you can simply go here and set this while you are in the right frame. Click here, so it will stay automatically marked the keyframe, and it's supposed to be 720. And now we can see that it's working. If you want to change the if you want to change it from counterclockwise to clockwise, of course you can swap the keyframe if you want, or more easily just add here the right sign. So in this case it's going to be minus, and now it's rotating clockwise. Then we go to let's say we go to Mercury, and I assume, I'm not sure, I'm not gonna check, this is just a, again, total disclaimer, there's no scientific relation in this license. But let's say that probably it will rotate faster, the closer to the sun it will rotate faster. I don't know how faster, but let's say it's gonna do a bit more than 2 revolution. Okay, and this is the result. And probably Venus, our Venus is gonna be in between, let's say like that. Probably this can rotate even more. And then we go to Mars. Probably the years are longer in Mars, so we can have, instead of 720, something like 600. And then we go to Jupiter and we do, it's massive, so I assume it's very slow. Oops, 500. And then we go Saturn, and it's going to be 350, 500, 350, let's say 300, and we'll do, okay. Now they're all over the places. And now when we go to the first frame and we just hit spacebar to play the animation, that's what happens. Now the first thing you notice is that all of the planets have an acceleration, while we want this to be linear. So the fastest way to do this, to change whatever is happening here, it's actually selecting all the objects and then we can change the interpolation to linear. Of course, the animation is not loopable at the moment because the alignment of the planets only will happen every, I don't know when. You need to calculate that. But if you look at the position of this planet, which is the Earth, you will see that actually as we made it do it 2 full circle, it will be looping. Okay, so you need to always, if you want to loop an animation, you need to have the first frame the same of the last one, or the last frame to be the same of the next to last. So they will be exactly in the same position, because at the moment we will have the 250 frame the same of the one of the first frame, while we want the 250 to be exactly as 249. So one thing that we can do, if we select this, for example, I'll show you quickly, is moving this a few frames out. So now we know that in 250 the next frame is going to be the first one, and if you see what's happening here, first one, last one, first one. So if we loop it, let's just look at this. We appear here, it's going smoothly all around. Hope this makes sense. But we're not going to do more than 10 seconds. We're not going to loop any animation, so it's good enough for now. Let's go to add some more detail. The first detail I want to add is the moon, because I think it's a very cool movement to add. So, sorry, go back to here. So what I'm gonna do, it's actually creating another object. And let's create it just up here, and we call it moon. Now this object rotates around the Earth, but rotates only around itself. If I scale this object, my origin is there, and if I want to rotate, it will rotate around the sun. That's not what happens. So we need to bring the origin back to its own center. If I create a sphere from scratch, that's fine. It will be already what we need, but I need to teach you how to fix this problem. So I select the object, very easy, right click, set origin to geometry will bring back the origin from wherever it is to the center of mass of the geometry. And here it is. At this point, I can scale it a little bit. I think it's 1/3 of the. I think it's 1/3 of the Earth. So in theory, well, let's say that's 26. It's going to be 0.75, 77. Oops. .077. It's too small. Let's make it slightly bigger so you can see that in the animation. Now, one thing we want to do is having the moon be a child of the Earth, because otherwise it won't follow. So the center of the moon, the center of rotation of the moon is going to be the Earth. So we select the moon first, then the parent, Control P or Command P, or if you want you can go to Object, Parent, it's the same thing. You see here the shortcut, it's Control P. And this is the problem we have, because that's the center of the Earth. But it doesn't really matter, because my object is following the relative position of the Earth, so it will just work. I hope this makes sense, what I'm doing here. We have a different problem. The problem is that if I want to rotate this around the Earth, how can I do? Well, I need to move its origin in the center of the Earth. So I'll go back here, origin, and G and Y, sorry, and then with Control, I'll move it here. And now the center of the moon, it's here. There's still no rotation, but you can see that it's already rotating. Okay, hope this is making sense to you. Working with all these relationships can take some time to get used to, and there are other ways to do this. Right now I show you how to parent this to a planet, to its parent. But actually you can create an object which is only a dummy object used to this kind of animation. I'm not going to go into that. Right now it's enough thinking that you can parent one object to another and it will stick to the relative position of that object. So right now we have a satellite rotating around a planet which is rotating at different speed from any other planet. And if I rotate this planet, nothing happened. And I'll tell you why. Because while we were doing all of this operation, we kept this active. So now this has a number of rotation already. So let's remove the keyframe. Let's remove this. You see what's happening? The moon, it's basically, it's like always in front of the Earth, of the parent planet. So we want to select the moon. Let's create our keyframe. The default is whatever it was in the Earth. The reason why we had keyframe in the moon is because we copied the Earth that was already animated. So it's good practice to create all your geometry before you do anything else, before you start the animation. But I wanted to show you something quickly, and we are just adding elements to the animation as we go. So it's also worth going through the problem solving process. Sometimes you have something happening like this and you need to know, how did it happen? How do I fix it? So if you copy an object with an animation, you will copy also the animation. So right now the moon is only parented to the Earth, and we're gonna create, well, we're gonna reset the rotation. We're gonna create single keyframe here, and then in 1 year, how many times the moon rotates around the Earth. And I'm sorry, but I cannot give you the answer, and it's not relevant for this tutorial. What we know is that we want this planet to rotate, and because I want to have a nicer animation, I'm gonna rotate that in the other direction. So instead of having 2 revolutions while the Earth goes around the Sun, we're gonna have, I don't know, just one. Let's see, just one. Oops, and see what happens. And nothing happened because I didn't save it. The other way. It's very slow, it's barely noticeable, so we're gonna make it rotate a lot. And then remember to replace the single keyframe that you have just changed it, because this is disabled. Okay, now it seems to be faster. Let's look at this portion of the animation. If we want, we can go even faster, just for the sake of seeing something that makes sense. Here you see the real-time keyframes, so sorry, frame per second. So at the moment I'm playing the animation real time, and yeah, you can see here how this is spinning around. And if I can zoom out, you can see the whole thing. Still, we have the same problem. This is start very slow. There is an acceleration, so we want to go here, actually even here, and interpolation linear. Now should be a bit more constant, the speed. Okay, hope it's all clear for now. We can add some elements, and let's add some disk around Saturn, because why not, right? And also we haven't seen how to make this kind of shapes, so I can quickly introduce to you another concept. We start creating a cylinder. So this one, it's a cylinder. We are only seeing that from the top. If we rotate, we see that it's a cylinder. And then we are gonna reduce the size, so we don't need this to be remove origin, otherwise I'm scaling the origin, and that's not what I want. Reduce the size. and we want to bring it where Saturn is, because like this it's hard to snap it right, and that's why I have to go from the top view. And now it's in the center, and I don't want this to look like it's looking now. I just want this to be a disk around. So what I'm gonna do is duplicate the cylinder with Shift D, press enter, then I'm gonna scale it only on the Z axis, just a little bit, then I'm gonna scale it completely, then I'm gonna select the external disk. I'm gonna add a modifier called Boolean, and the Boolean modifier let me remove or connect different shapes or having an intersection. We seen the Boolean in many other software, so it's the same concept, just in 3D. Once you select the modifier on the object that you want to keep, you select the operation, is going to be difference, and it's going to subtract the second object. Did it work? Yes. The second object, though, it stays visible in the scene because I may want to reuse it, so it's not going to be deleted. I'm going to just remove the visibility, and here is my disk. It's exactly what I wanted? Probably not. I can just now fix it a little bit more. I will probably make it, yeah, let's make it, scale it the Z, and then what I want is rotate, because probably it's not going to be flat, it's going to be at an angle. So once you are happy with the operation, you can click on apply. That means that you don't need anymore the initial shape. You can remove the object. Let's call it Saturn rings. It's one. We can create two if we want, actually. So Shift D, and then scale it. And now we have more rings. They are both too big. Let's scale them down. So now we have two rings. We select them both, as we don't need them separately. We select them both and we'll join them. Join. So now we have only one object called Saturn rings, and we don't need this automatic number that it's added there. So we have these rings here. They are not perfectly in the point I want. Actually, they should be in the center of the object, but they are not. So let's go here. And what we noticed, which is nice, okay, and we still notice that all the objects are actually slightly down compared to the equator of the sun. Okay, so we can actually select everything, or better, we can select all the objects, all the planets, and we can just bring them a little bit higher. Doesn't need to be precise for this animation, for sure. And now we can tilt this a little bit, and again, not being anything scientific, we just tilt it to be something we like. We'll tilt it a little bit like this, and probably on the other side too, so on the X. Okay, now we have this problem, but easily to be fixed. Select the first object, select the second object, Ctrl P, and now they will travel all together. hope it's making sense till now, till this point. Let me save the file. I'm gonna include this file in the description of this lesson, so you can just download it and play with it a little bit. I'll just save it for now anywhere on the desktop, right? And go back to what we need to make this a little bit better looking. It's some material. So we're gonna, first of all, we need all the objects to have no flat shading. We want that to be smooth. So right click on all of them and make them smooth. Even the Saturn's rings, we don't need to see the sides. It's very low resolution at the moment. You can increase the resolution of everything. In this case, just adding a subdivision modifier if you want. You can even add something like that here, and you will see a weird artifacts coming in. So there are ways to fix it, and that's not what we want really, but at the moment we are happy with this kind of with this level of detail. Colors. We select the first object, which is going to be the sun, and we go into the shader editor. We create a new material. We want to preview the material, so we click here on material preview, and I'm going to introduce today a number of different options that I didn't show in the previous time, in the previous lessons. So the sun, let's name the objects, let's name the material so we know which is the material we are editing. Sun, and don't forget you have the same settings on the side, but this is where we will work most of the time, so I'm showing you all the settings from here, but I'll leave this open so you see how it change. The sun color, well, the sun actually probably has no real color, it's just a very strong source of light, but the perceived color is probably something this strong. And what I did, it's actually enable the emission, because the sun emits lights, so we want that to have no real shade inside. It's gonna be very, very simple material, okay? It's not nothing realistic, just to have an idea again. So you will see the difference between something with the emission on and the emission off. If I remove the emission, you can see that it seems almost a solid instead of source of light. It's actually receiving the light. In fact, if I rotate my environment, you see the light changing, and there's nothing that can change how much the sun is bright. The sun is the source of light, so we need to increase the light, probably keeping some kind of shade, just to make the illustration a bit better. And also there's no roughness in the sun, so there's no it's not reflecting anything in the sun, so we're gonna put the roughness to the maximum, and that's it. And that's the first thing. We'll go quickly to the next one. So Mercury and Venus, I really don't know the color, but let's select Mercury, new material, Mercury. We can zoom in a little bit. Okay, and then the base color Mercury, let's say something like brownish. Doesn't really matter. It certainly is not shiny. And we start playing with a node that it's called noise. We have many different kind of noise node. Texture, noise texture, and we start with the basic ones, which is called noise. And I can add the output of this noise texture to the color output, and I will get some kind of noise pattern, but I don't want this color. So let's remove this for a moment. I'm gonna add a ramp, color ramp, where I'm gonna set the color that I want in my noise, and the color ramp, it's a gradient, and let's say that I want this to color. Let's start with this. I'm gonna output this here, but I don't want the color to be one side black and the other one brown. I want this to be the colors used by the pattern of the noise. Okay, so now I have a number of different colors. You can play with the scale to have different kind of well, shades. I still see some roughness here, and we don't really want any. It's okay having some shade part, but we don't want any roughness going on, any shininess going on the planet. Let's move on to Venus. I'm gonna try to be as quick as we can to give you an overview of what you can do with material. Venus, we're gonna use another we're gonna still use the converter color ramp. I don't know why people have problem with my volume. Hello John, unfortunately my volume is the maximum. I don't know if maybe YouTube decreasing the volume somehow, or if you can increase your own volume. I really am at the maximum volume. It's all boost up on my computer. I really don't know what to do else. I can actually try to do something else, but it's not gonna be too nice. People tell me I'm going to test something, and you can tell me if it's gonna work for you. Is it any better? Okay, so if now the volume is too hot, please reduce your volume. It's important for me that you can hear me clearly. I just increase it in a very, very bad way, so the quality may be worse, but if you can hear me better and louder, it's okay. Hello John, I don't know, you may be younger than I am, so maybe my age. Okay, great. I'm happy that you can hear me better now. So back to the color ramp. Venus, what color is gonna be Venus? Let's say that it's gonna be something feedback noise. Well, I imagine that we're gonna have feedback noise. So what I can do is reduce it again, and let's hope that it's gonna be any better. So some people hear that, okay guys, once for all, from now I'm gonna wait like 30 seconds because there is some lag with your answers. Can you tell me if like this it's good enough for you? If there is too much noise, I'm going to reduce it again. Can you please all give me a feedback? We're almost at the end of this tutorial, but I would like to know it for future lessons too. Sam, Mariana. Perfect still. Okay, so I assume that good. I assume that it's the streaming itself that does some I don't know, some kind of filtering and amplification, compression to my sound, because I never changed it from my first lesson. So okay, all good. Reduce it again as long as he's happy. All good. I can hear. Yeah. Okay, I hope the noise is not too bad. I will do some more tests later. I'm very sorry for these problems. I think it doesn't depend on what I do really. I will just run some tests to see what you hear really. Okay, I'll move on to the next planet, Venus. We're trying to give some color to Venus. Let's give some I don't know, from blue to some more interesting color, and we'll use again a texture. Let's use the same texture but with different parameter. Okay, Rich. I'll try to put it back and see if anybody complain or not. Planet Venus. Put it back to the normal levels, how they were, and now, okay, now should receive the audio as it was at the beginning of the lesson. Let me double check. Okay, it's very loud. If you ask me, I see the signal that almost always goes up to the maximum, which is not any good. Hope it's not too noisy now. Planet Venus colors. Let's link the color ramp to the noise texture, base color, and this time we'll add this other effects, which is some distortion, so they have slightly different pattern. Also roughness, it looks a bit too bright. I don't think there's anything that's saturated in space. Doesn't really matter at this point. Okay, and then we go to planet Earth, and we know this planet, so it's gonna be all different shades of blue and green, hopefully. And so converter, color ramp, and texture. We're gonna have a yeah, let's do with the noise texture again. And we're gonna go to from this blue to this green. I wish that, well, that's a bit too toxic. It's not the right moment to do this kind of things. And then we can change this to have more detail. And I want to increase only the blue spaces. Of course, it's not precise. You can add an image and having the Earth exactly looking like the planet Earth, but these are going to be all only procedural, non-destructive way to work. And again, it's just an illustration, so it's gonna be fine. In order to change the way it looks, you can add a new node, and in our case, it's gonna be a let's see what we can add, a bright contrast node. So if I just leave the node in between these two, I can change the contrast of some area, and then this is what happens. Now I have a bit more what I thought, and I have less land than in reality. It's a very random planet, and we can scale it, so we have bigger continent, for example, and now we have a Earth-like planet. We are not gonna do the poles right now, but what we can do is assign different material to different part of the objects. I'm going to post a link to a tutorial just to do that, but we go quickly to the next one. Roughness, that's okay, to the maximum, we don't want any roughness. While I'm saying this, actually I would like to have some area, like the blue area, to be shiny, while I want the green area to be not shiny, because normally the sea, it actually reflects light on our planet, so we can spend some time to show how to do that. The parts that I'm interested in are these two, 1 and 2, okay? And doesn't matter what's the color, I only have shine and not shine. So I select these two nodes, I'll duplicate them with Shift D, and I output this to the roughness. And now you can see that I have some reflective part and some that are not. It's reflecting our environment, it's not reflecting the object in the scene, but it's a quick way to show you how can you work with nodes. The reason why I duplicate them, I could have done the same, I could have achieved the same object effect if I would have dragged from here and into the roughness channel, because it's exactly the same parameter. But if I have another network, it means that I can edit these bits without changing the color, so I will change only the noise that it's used for the roughness. Right now they have exactly the same settings, so they will work exactly in the same way. But let's say that I want just to change the contrast and the brightness, but I don't want to change the noise type. I can also do this, sharing the noise but not the contrast. So right now I may want to have more contrast or less contrast, and you can see how it's changing in real time. Right now I have only some area that are shiny, even on the sea. But that's not what I want to do. Actually, what I want to do is having the shiny area a bit less shiny. So right now it's from dark, it's from black to white. So I'm gonna add another color ramp. And if I add the color ramp, nothing changed. But if I start moving this, again, nothing changed. So what I want to do, it's actually, no, sorry, not the white, going to the black, which defines the area that is completely shiny, and raise that until I'm happy with the result. Okay, now I have some lights, some kind of reflection on the blue. Again, this is nothing perfect. I actually wanted to mention, yeah, that it's a corroded planet at the moment, Sam, which is actually what it is. But I'm going to share with you in the description of this lesson a great 1-minute tutorial from CG Geek, which is a very famous channel. He just released a couple of hours ago a beautiful, fast and packed with information, so you need to understand what's going on a little bit, but you can pause and see all the single steps using images, how to make in 1 minute only, a beautiful realistic Earth. So it's not going to use any of these tools, but I'm just showing you all these tools to just to know how to work with the node and the shading network. For example, if we go back to Venus a second, we can decide that the let's say that the blue part will emit some light. So we have to take this Yeah, Brian, I've seen that, and well, they are amazing. I mean, he is amazing, and the tutorial, it's very, very good. It's a great result too. So let's say that I want some of this noise. In this case, I use the roughness. In this case, I use the noise to define the roughness of some area. And in this other case, I may want to use the noise to define how bright are some area, how strong it's the emission of the light. Actually, we're gonna do this with the sun, because the sun is probably not a full, when you take a proper photo, you see some area that are less strong than others. So one thing I can show you is that you can copy one node from any material, go to the other material and paste, so you have exactly the same setting. What we want to do, it's actually having the usual color ramp. Well, let's start with this. We just link the this channel to the emission, and now you have something that, of course, it's white because the emission is normally white, but it looks a bit more like those close-up of the sun. We're gonna add again a color ramp, and our color ramp will go from white, which is okay, to let's say from yellow to orange. Still too bright. Okay, let's make it less bright. Yeah, and let's move it a little bit. Okay, so again, I'm not gonna make it like perfect, but it's just to give you an idea of what you can do with material. Now we can copy, let's say that we copy this material all together, just these two nodes. Let's go to the moon. I'm going to show you a different node this time. Create a new material, we call it moon. Let's move quicker now. And the moon color probably is going to be, we're used to see the moon as no color at all, so it's going to be gray with craters of some kind, so gray on gray. And what we're going to do, actually, having some, not the roughness at the maximum intensity, but we're going to use this other channel called normal. So we need a bump node which connects to the normal, and then we use the same node to the height, and we can reduce slightly the strength, let's say to 3. It's probably even too much, and we'll also invert it. Okay, now we have some area. I'll show you without, so you see what's happening exactly. This is without, and this is with. It's basically give it some, oops, I'm going around. It give it some kind of bumpness. That's why it's called bump. If you remove the roughness, you see this effect even more. It looks like a shiny marble of some kind. Probably it's not that shiny, but now we have our couple of planets. let's go quickly to Mars. Mars, we can copy the setup of Venus. I guess nobody will complain. New material, let's call it Mars. Oops. And we're gonna make it more red. Well, let's say from these two. These we don't want any kind of. Then we're gonna go to Jupiter, and Jupiter we can do something, but this lesson is going to be longer and longer, so I want just to go through all of them, then we can go back to some of them and edit them even more. Let's go with Jupiter. We still have the copy in memory, so I'll just paste it in this case. Jupiter, it's always in this creamy color. Not really what I want to do. It's too dark. Okay, quickly I can explain to you something. The way that these materials are attached to the objects are called UV. Okay, it's the coordinate system that it's used to map images around or on top of any object. So normally an object has some standard default mapping how to say mapping coordinates. Imagine the mapping coordinates like the world map around a sphere. Okay, the way that the world map will wrap the sphere, it's decided by the UV coordinates. We're gonna have a lesson on that only because it's a complex topic, but I want to show you that you can change quickly the way this noise texture will be visualized. So sorry, what we need is something that takes the texture coordinate, the mapping coordinates, and then we're gonna let's see what we can do quickly. Mapping, so we'll use the generated coordinates and then we'll put them there, and nothing will change initially, but then I can scale it. Say that we scale this a little bit, and now I have some kind of stripes. Let's make them stronger. Let's make the other stronger and probably brighter. So you see a difference. I just changed the coordinate system of the noise texture. Rich, we're gonna have a lesson on UV maps soon, but this time it's only a brief mention, so you can see that you can stretch an image and achieve completely different result. So this is just a quick overview of how can you edit a texture. In this case it's a noise texture. It's called procedural. That means that it's non-destructive and they have all the parameters, but this could be an image. This could be a normal rectangle image that you can apply to your object. And we are not going to do this. We're not going to do it in our lesson, but if you follow the tutorial of 1 minute Planet Earth, it will be amazing for the amount of information to do exactly that. Let's select Saturn, and Saturn is probably going to be very similar to Jupiter, so we can copy the whole thing and then new, we call it Saturn, paste it here. Oops. And then we can, for example, rotate this a little bit, not this, Okay, so it will look slightly different. And then we can probably change the color again. Another thing we can do is probably rotate the object itself, but not for now. Let's move faster. Now, the rings of Saturn are usually semi-transparent. I'm gonna Saturn's rings. So we're gonna have just a normal, quick kind of cyan color, and actually not that saturated for sure. And I'm gonna make it semi-transparent. There are different ways to do transparent object. This is the quickest way. It's changing the alpha, but don't forget that you want to go into option and say that it's gonna be blend mode. It's alpha blend. So now it's semi-transparent. Of course, it depends on the angle of the light. So what you can do is actually remove the back face and also make it even more transparent. Okay, this is not any realistic material. It's not a glass. It's just a very semi-transparent piece of graphics for this tutorial only. You can see through. That's all we need at this moment. For the last two, Uranus and Neptune, we're gonna do a quick, very quick let's add some noise, something more like Venus. Color, base color, and we make it, I think, something like this. Two colors are too similar, and then the last one, you're gonna change altogether the look of it. That's it. And that's it actually. I'm gonna save it. I'm gonna remove anything on the scene. And our let me enable the timeline. And here we have our very simple animation of the planets rotating with satellites and every other object around the sun. One last thing you may want to do, actually, if you go into the final view, and then we can, for example, change the color of the background. Okay, and now you see what I meant when I said that the sun is emitting light. With the dark background, you can clearly see what's going on. There's no light in the scene, it's all black, but the sun, it's visible. So not being in a real light, it's only an object with emitting colors. It's not gonna illuminate for real any other object. What you can do, it's actually increasing a little bit the background, and you see the objects are very dull, and that's why we usually use a different way to illuminate the scene. One quick way, it's adding a light, let's say a point light. We could add a point light, and then we should spend more time on this because it's a very complex topic, and I have to finish the lesson, but the point is that if you use an HDRI image like this one, you can illuminate much faster. Let's say that we use a studio, for example, HDRI. This is what it's gonna look like. A way to get a black background very quickly, so you can see the sun shining. It's adding a sphere. That's something that I do often because it's faster. It's adding a sphere, scaling the sphere bigger than anything else, smooth, and assign to the sphere a material which I will call it dark background, all rough and completely black. It's not completely black, but it's much darker. So right now you can see what's going on here. Everything is darker and the object have a different material. I just realized that I didn't remove the Jupiter roughness. It's still actually a bit shiny and looks like a piece of wood. That could be what you want, but it's not what we're gonna have in this tutorial. The last thing you may want to enable, it's a gimmick in this case, but we want to do it every now and then to have fun. Wait, even Saturn is actually not rough. Okay, now Saturn is rough again. It's in here some bloom, and the bloom it's going to be visible on the sun. Let's the radius not be too strong, and that's it. So only objects that emits light or objects that have a big enough a bright enough color will have this kind of glow effect. Okay guys, it's all for today. I hope you enjoyed this lesson, and we're gonna have another lesson this week, if not tomorrow, the day after, roughly at the same time, and we're gonna keep it from there. In the description I'm gonna leave the file with this very simple planetary system and a few links to other tutorials that may help you to progress with shading, like planet shading, like the CG Geek tutorial of 1 minute, and a few more resources. Thank you again for today, and talk to you soon. Bye guys.